This is Emily Hutchison talking about number 19 from chapter 14 for the midterm one. The problem reads, for a lottery to be successful, the public must have confidence in its fairness. One of the lotteries in Maryland is a pick 3 lottery with 3 random digits are drawn every day. A fair game depends on every value 0 to 9 being equally likely at each of the 3 positions. If not, then someone can detect a pattern and take advantage and then beat the lottery. To investigate the randomness, we'll look at data collected over the recent 32-week period. Although the winning numbers look like 3-digit numbers, in fact, each digit is a randomly drawn numeral. We have 654 random digits in all. Are all the digits from 0 to 9 equally likely? Here's a table of the frequencies, and I put all of those into this jump data table here. And then the appropriate procedure for part A is going to be a chi-squared goodness of fit test. And then for the assumptions, we assume that the lottery mechanism uses randomization, and then that it also is that the numbers pulled are independent of each other. Also, the expected frequencies are all greater than 5. So then for part C, to state the null and alternative hypothesis, the likelihood of drawing in each numeral is equal, and then the alternative is that the likelihood of drawing each numeral is not equal. So we pull up the distribution module after going and analyzing the number pulled versus the count. So we're going to go here to number pulled hotspot, and we're going to go to test probabilities. And then what this is asking is saying that all of the probabilities are the same, so then there would be 0.1, since there's 10 outcomes, and 1 divided by 10 is 0.1. So when you enter all those probabilities here, and then we're going to go to done, and then we're going to look at the chi-squared Pearson output, which says that our chi-squared statistic is 6.4587, our degrees of freedom are 9, and the p-value is 0.6933, which means we fail to reject HO and conclude that they were all drawn from a fair, that they all have the same probability of being drawn.